All right, so this is the second part of your final review, your final for next week. So we're going to do 19 through 40, and then we'll be done. This first one says, solve 4x minus 11 is less than negative 3. What do I do?
Add 11.
I add 11. I add 11 to both sides. I get 4x is less than 8. So x is less than
2.
2. All right, this does not say to graph it, so I can stop there. Write the sentence as an inequality. Okay, so here you have some key words. Those words being more than and no more than. So it says a number b times 3 is more than 19. So what's a number b times 3?
3b.
3b. What is more than 19? Greater than 19. Okay, number 21 says a number x is no more than 48. So no more than. So we have x is less than, is it just less than or less than or equal to?
Less than equal to.
Less than or equal to. Yeah, it can be 48 or lower, right?
Yes.
I want to make, no more than 48 cookies. So 48, 47, 46, right? That all works. Any questions about 19 to 21? No? All right, let's move along to the next slide. So you want to pay particular attention to number 22. This is probably one of the hardest of the group questions in your 40 questions. It says, write the absolute value inequality shown by the graph below. So the very first thing you want to do is determine what this number is. What's that number?
7.
Negative 7. What's this number?
Positive 7.
Positive 7. So you have to come up with some sort of absolute value, right? And it has to have something, and you have to have that 7, right? So the tricky part with this is it's not going to be equals. The reason it's not going to be equals 7 is because there's some shading, right?
Yes.
Anytime there's shading, that means it's not going to be equal to. So we have to decide, is it going to be greater than or equal to, less than or equal to, greater than, less than, right? So it depends. First of all, is it going to be any of these with the line on the bottom?
No.
No. How do you know that?
Because it's an open circle.
Because it's an open circle. So we can eliminate this. Does that make sense? So we have to decide, is it this one or this one? Well, in order to make a decision, we have to remember one tricky thing. And you might want to write this on your one-page sheet. If you're watching this because you're not here today, you are allowed one full sheet, front and back, to put whatever notes that you may need. So if, for this absolute value, if it's away, if it's facing away from your x, that is when it's an and. If it's facing towards your x, then that's when it's an or. Does that make sense? So in this case, I'm going to face this away from my x because I know this is an and, right? How do I know it's an and? Because it's connected, right? They're meeting each other. Does that make sense?
Yes.
That's how I know it's an and. So this is what it would be. So it would, this blank, so you're not confused here, is this. Does that make sense? Because if you split it up, you could split it up as x is less than 7 and x is greater than negative 7. Yeah?
Wait, so what do we write?
This. This is your answer. So this, your answer is, let me circle your answer. This is different. Okay? Because what makes this difficult is they want you to look at the graph and come up with an absolute value. So this, like I said, is the hardest one. In the grand scheme of things, if you miss this one, it's not going to kill you. But if you're watching this video, hopefully you're going to be able to see it and it'll make more sense. So I'm going to go over it just one more time for you. I knew that this was an absolute value because A, they told me it was an absolute value. The next thing that I did was I determined that I'm dealing with negative 7 and positive 7. The next thing that I did was I saw that I have open circles. So I'm either dealing with a less than or a greater than, right? And then because I have an and, I know that it's going to face away from my absolute value. Yeah? If I were to split this up and actually solve it, I would get the graph. So it would be x is less than 7 and x is greater than negative 7, which when I graph that, it would look like this. Does that make sense?
Yes, it is what it is.
Okay. So, microphone's on. Says determine whether the value n equals 12 is the solution of the inequality. What do? I plug it in, right? Like a Glade air freshener. So, 12 minus 14 is less than or equal to negative 6. I have to determine whether or not that is true, right? So when I take 12 minus 14, what do I get? 12 minus 14 is negative 2.
That's true.
It says 12 minus 14 is less than or equal to negative 6.
Yeah,
Negative 2 is...
So is that right or wrong?
Wrong.
That's not correct, right? So that's not a solution.
take a walk.
Okay, do we have any questions? Okay, this says solve the inequality and graph the solution. This is tricky because anytime we're dealing with absolute values and inequalities, meaning less than, greater than, less than or equal to, greater than or equal to, we have to figure out if it's an and or an or. So we're going to use what we knew about the previous slide, or what I taught you in the previous slide. If your inequality is facing away from the absolute value, what did I say that was? An and or an or? An and. Right. So this inequality is facing away from the absolute value, so it's an and. Okay? So, in other words, when I split this up and solve it, which I'm going to get 2x minus 4 is less than or equal to 2, and, okay, that's the key, 2x minus 4 is greater than or equal to. Now, with absolute value, you have to have a negative somewhere, right? So two things are happening here. You're flipping the inequality, and you're making what follows it a negative. Remember that?
Yes.
Okay, so you just add 4 and add 4. 2x is less than or equal to 6. So x is less than or equal to 3. And okay, when we solve this, we add 4 and add 4. 2x is greater than or equal to 2. So x is greater than or equal to 1. So that's an and. They're going to come together. Do you remember how to combine it so that it's just a single inequality?
Yeah.
Always start with which one? There's no negative there. Start with the...
Start with the less number.
Yep, start with 1. 1 is less than or equal to
3.
x is less than or equal to 3. Right, there has to be an x in the middle of that. Got it? So don't just say 1 is less than or equal to 3. 1 is less than or equal to x is less than or equal to 3. And now you can graph that. So just graph a few points. 0, 1, 2, 3. Are these going to be open or closed? Closed. Closed at 1. Closed at 3. And they meet in the middle because it's and. Okay, that is as hard as it's going to get. These last two problems. Or this one and the one before the last one. Do you have any questions about these? Because they are the most difficult. Okay. I would normally let you, but we're recording. So it says find the value of x so that the function has a given value. What do?
Plug in 23 for NX.
Plug in 23 for n of x, right? So 23 equals negative 4x minus 5, and then what do? Hey, somebody other than the same person who's whispering.
Oh, wait, you know what you do? You put negative
23
4x.
times negative 4.
Wait, what?
23. Negative 4 times 23, so you'll plug 23 into x.
No. I change. Okay, no.
Oh.
Hey,
You
this
add 5 and then divide it.
Okay, the first step was it said n of x is 23, correct?
Yes.
Yes.
So I replaced n of x with 23.
Yes.
Does everybody understand
Yes.
that?
Yes.
Okay, and then I'm trying to solve for x, so what do?
Add 5.
I add 5 now. So I'm going to add 5 and add 5. So I get 28 is equal to negative 4x.
Divide by 4.
Now I divide by 4 and I get what for the value of x?
Negative 7.
Negative 7. Okay, Brian, are you dying over there?
I'm doing it on purpose.
Okay. Do you have any questions? No questions.
No, Miss Wynn.
All right.
Wait, what? Oh, plus.
All right, number 26. So we're going to evaluate the function g of x equals negative 4x when x equals negative 9. So unlike the last one, we replaced the number with the f of x or g of x. So what are we replacing with negative 9 this time? Replacing with negative 9. X. That's the difference. So what I'm finding is g of negative 9, which is equal to 4 times negative 9, which is equal to what?
36.
Like the last one.
Because that was different. X equals negative 9. The whole problem was the and x equals 23. So you have to replace nx with 23. And
Yeah, that's exactly right. So let me go back to the previous problem so you can see the difference. This one said the entire thing, n of x, was equal to 23. So that's why we had 23 here. This next one says just x equals something. So we just replace whatever we see, like x equals something, we replace the x with. If we see g of x equals something, we replace with g of x. Does that make sense? Okay. Okay, so yes, as Troy said, our domain is all of our x's, and we're going to go in ascending order. So we're going to start with the smallest one. And so we said it was negative 5, what? Negative 5,
4.
negative 4, negative 2. Negative 1 is not a point here. So what about our range, starting with the smallest? 2, 3, 4, 5. Good. Move on. Do you have any questions about 27?
now Miss Wynn.
Okay. Right. Finding the domain and range of this. First of all, is this continuous or is it discrete?
It's continuous.
Why is it continuous?
Because
No,
it's
it's not.
because it's connected.
It's connected.
But
Because
it's not all
con-
real numbers because there's no arrows on it.
Right.
It has
And so a couple things we need to know.
Exactly.
Why is it continuous? Because it's a connected, well, not line, but it's connected, right? If it was disconnected, like the previous slide, we have disconnected points like this, that's discrete, okay? If we have connected anything, like we have here, these are connected by this little swirly line, then that is what's known as a continuous graph. As Jenna said, when we're looking at domain, it's not all real numbers unless we have arrowheads at both ends. So, Troy, do you remember the domain? How to find it for a continuous
Yeah, you
graph?
go left to right.
Left to right. So going from left to right, we would have negative 4.
Those three are better.
Would it be less than or equal to or just less than?
Less than that. No, less than.
Just less than. Why? Because the circle is open here. Less than x. Why x? Because domain is x. And that's less than positive 4. Remember, left to right, looking at our x's. Negative 4, positive 4. Now, up and down, looking at our y's is our range. So what's our smallest y?
Negative 3.
Negative 3.
less than or equal to y, which is less than.
It's not like. It's
Oh,
not
less
like-
than, less than
Y.
5, which is
Less than 5. Perfect. Yeah. So we're good there. This says identify the equations that represent linear functions. Circle all that apply. You will absolutely have an all that apply one. Is the first one a linear equation? Somebody says no.
No, it's not.
How do you tell if that is a
That's a great question. So there are a couple ways we can tell whether or not something is a linear equation. The first way is to, anyway, so the first way to tell if it's a linear equation is to see if it fits the form y equals mx plus b. Remember? So you're going to have to do some rearranging. Well, for this first one, we have a y and we have an x. If it's anything else, if I have like a radical, then that's a no. If I have bars around it, so if I have an absolute value, that's a no. Okay, if I have an x on the bottom, that's a no. The x has to be on top, right? So we have to decide between A, B, and D. And they're all linear, and I'll tell you why. The first one, we can get in that form. Because if I just add 6 to both sides, I end up with y equals, and then I distribute that negative 5. Negative 5x minus what? When I distribute the negative 5? Minus 40. And then I add that 6 to the other side, right? So I end up with y equals negative 5 minus what? 5x minus 34, right? Do you understand what I'm doing for A?
Yes.
I'm just getting y by itself. So I distributed that negative 5 and then I added 6 and I ended up with this. Is this of the form y equals mx plus b? Yeah,
Are we
it is.
crossing off? Are we putting an X to all the ones that don't work?
Yes.
Oh,
So this works, right? A works. What about b? Is that linear? Does it form a line? It does.
Oh yeah.
What kind of line?
a not.
Please don't say
Slope
it
of
straight.
0.
A slope of 0, right? Which looks like that. Right, horizontal?
Got you.
Perfect.
And then when it's going up and down, like this, it's undefined.
Yeah, undefined slope. Okay, and what about D? Is that linear? Is D linear?
Told us it's linear.
Yeah, how do you know it's linear?
Because it's
Other than I told you.
You have to solve.
You don't have to solve it. What form is this in? Not y equals mx plus b.
Oh,
I don't
it's
have a
A.
y equals. ax plus y, ax plus by equals c. Do you remember what that's called?
something like that.
It's called standard form.
Yeah.
So when you're watching this video back, make sure you know the differences between all three types. You have horizontal and vertical lines, which are linear. You have y equals mx plus b, which is slope-intercept form. And you have standard form. The rest of these don't work. E doesn't work because you have an x in the denominator. F doesn't work because you have absolute value. And C doesn't work because you have a radical. Have any questions on that? Okay, great. Let's move on. All right, it says, for the equation y equals negative 3x plus 4, name the slope. What's the slope?
3.
Negative 3. Thank you. Remember, y equals mx plus b, m being the slope. Okay? Please watch this video. Please. Okay, so negative 3. What's the y-intercept? 4. Okay, so I'm going to graph it. Where do I start? Where do I start, Troy?
Oh, if you graph it,
Yes.
you start at 4.
Okay, and then where do I go from there?
Well, it's negative 3. So you go down 3, and then you go over to the right 1.
Yep.
And you just keep moving.
All right. That makes sense, right? Because our slope is going downhill, so it's negative. Questions? All right, move on. 31 says, find the slope of the line passing through the points. You have 2 points, -2, 3, and 4, 5. How do I find the slope between those 2 points?
You put it on the y1 minus y2 over x1
Yeah.
minus x2.
y2 minus y1 over x2 minus x1. It doesn't matter which y you start with. You can start with whatever y you want as long as your x is in the same position. So, for example, if I start with 5, and I say 5 minus 3, what would I have to start with on the bottom? 4. If I start with this 5 at the top, I'm going to have to start with this 4 in the bottom. 4 minus -2. If I started with 3 and I said 3 minus 5, what would I have to start with in the denominator?
-2 minus 4.
Yeah, -2 minus 4. Same thing. So we'll just do one of these. Let's do the first one. 5 minus 3 is 2. 2 over 6. What's 2 over 6 reduced to? 1/3. Always reduce. 1/3. Simplify. Questions on 31. 32. Okay, Autumn says write the equation of the line with a slope of 2/3 and y-intercept of -3. How do I do that? I don't know. Well,
Oh, you have to write out in the equation. Like y equals 2/3.
2/3 what?
X
Yeah?
minus 3.
Perfect. Number 33 says graph the linear function g of x equals 1/3 x minus 2. Where do I start?
2.
2 or -2?
-2.
-2. Then where do I go from there?
Go up 1/3, down 1/3, up.
Up 1 or up 3?
Up 1.
Up 1, over to the right how many?
3.
1, 2, 3. Or down 1, and then what?
Oh, to the left. 3.
Yep, over to the left, 1, 2, 3. So either direction works. Remember, up means positive, right means positive, down means negative, left means negative. And that makes sense because I have a positive slope, so I'll be going uphill. Do you have any questions about that? Starting point, your y-intercept, -2.
I was going up. My grades.
That's good.
It's not mine. But not like next.
Not in biogender. That's true.
Okay, let's move on. Okay, what's the slope of this line?
0.
0.
So,
0. Remember we had the little skier dude,
it was Troy, wasn't it?
and then he was like falling asleep here?
Whoa.
It was Troy, wasn't it?
All those Z's? 0 slope? Alright, so continuing with the recording here. Find the slope. What's the easiest way to find the slope?
Go down. How many over?
Yeah, you can just
down
count,
3.
right? So you have a couple options. So
Go
if we
down
start
3.
here, go
Rise or
down.
run?
Yep, we go down 1,
It'd be negative.
2, 3, negative.
It'd be -3.
And then
negative,
1, 2, 3, 4, 5, 6. I'm going to the left, so is that negative or positive?
negative.
Negative. Right?
Turns into 1.
So -3 over -6 is positive 1 over 2. You could also start here. You could also start with this other point here and go up 1, 2, 3. And go to the right 1, 2, 3, 4, 5, 6. So 3 over 6, which is also 1/2. Do you have questions on that?
No. Thank you. You're just a really good like.
Okay, is number 36 a function?
No.
Because -1 repeats. So it's not a function. Right, -1 is paired with -4, -1 is paired with 4. So not a function. Great.
Can't the x be paired twice?
No, the x's cannot be paired twice. Well, because if you think about it, think about a graph. If -1 is paired with +4, right, and -1 is paired with -4, if you draw a vertical line, it hits that and it hits that, right? Okay. What about 37?
No.
Why is 37 not?
repeats 30.
Yeah, 3 is paired with 12. 3 is paired with 24. Now what if this was switched? What if it was 12, 24, 3, and 3? Is that okay?
Yes.
Yeah, because your outputs are okay if they're paired with if they're the same. Any questions? All right. Is number 38 a function?
Yes.
Yeah. What does it pass? The vertical line
Vertical
test.
line test.
Wait, was 37 yes?
37 was no, and 36 was no. 38 is yes.
So we don't have to explain it, it doesn't say
Unless that's a great question. If it says explain, you'd have to explain and say it does not pass the vertical line test, right? But it does not say. Okay. What shape is number 39 going to make? Aiden, what shape is number 39 going to make? What shape is number 39 going to make? A V shape. Okay? What makes it make a V shape? The absolute value. Got it? Okay, so we're going to start with our vertex. What is our vertex for this? Right, if you're watching this on video, make sure you pay very close attention.
Your vertex is going to be 1. Oh, wait, no, okay.
Am I moving to the left or right at all?
What?
Autumn, am I moving to the left or right at all?
No. 0.
How do you know I'm not? How do you know I'm not moving to the left or to the right? Am I adding anything on the inside of the absolute value? I'm not adding anything inside the absolute value, so I'm not moving to the left or right. Am I moving up or down? Anyway, so your vertex here is 0, 0. You're not moving to the left or right. You're not moving up or down. Okay, so that's our starting point. That's our base point. So we always start with that base point. Do you remember what we do next? Take 1 point to the left,
big one. Wait.
negative 1. 1 point to the right. If I plug in negative 1, 2 times the absolute value of negative 1 is 2. So if this is 2, what is 1? 2. Why? Because of symmetry. So, 0, 0, negative 1, 2, and then 1, 2, and then I form my V shape. So, right in this recording here, for an absolute value, you start at the vertex. Your vertex can be found based on what you're adding or subtracting on the inside and what you're adding and subtracting on the outside. If I had something like g of x equals 2 times the absolute value of x minus 1 plus 2, my vertex would be 1, 2. Why is it positive 1? Because it's the opposite sign of what's in the absolute value. That would be your base point. That's where you start. And then you go 1 to the left, which would be 0, and 1 to the right, which would be 2. And you plug in 0, tell me what you get, and then that would be your output, and would be the same for the 1 to the right. Does that make sense? All right, one more. Does this represent a linear or non-linear function?
Why do you ask?
Well, why would you say it's linear?
Because it represents a constant.
Oh, this is
Not a
it's
constant rate of
linear
change.
Because y is not a
The y is not, you're not adding or subtracting a constant value on y. Okay? If you're not adding or subtracting the same value on all of your y's, then it's not a constant rate of change. Are you adding something consistently across your y's?
No.
No. So it's non-linear. Okay, this is your review. It mimics your final. You need to watch this video a couple times at least to make sure that you understand everything.